Now it's time to look into one more tool. So we have seen the manual setup of Kubernetes cluster. We have used Docker desktop with Kubernetes extension to set up a single node cluster. Then we have used Minikube and Docker to set up a single node cluster. And then we have used kops to set up a multi-node cluster on Amazon Web Services. Then we are going to look into kubeadm, a kubeadm to set up a multi-node Kubernetes cluster and can be created on any platforms such as VMs, virtual machines, EC2 instances, or physical machines, wherever you want. So let's look into the installation. So kubeadm, so installation, basically this slide shows how to install kubeadm toolbox. So kubeadm, you can just get into the documentation of that, and let me get into the documentation and show you that. Kubernetes.io, kubeadm, and this is our kubeadm documentation. You see that here you will find out how to install. Let me click on installation guide. So before you begin, you should know about minimum requirements are this: a compatible Linux host and 2 GB or more of RAM per machine and 2 CPUs core and full network connectivity between all the machines which are inside the cluster. It could be a public or private network, whatever it may be fine. Then unique host name, MAC address, and product UID. Certain ports are open on our machine, so swap disabled. That's one more thing. Okay, this is the prerequisites. Once you have all this information, then you can go with your further procedures. You have to check adapters and installing container runtime. We have to install it one by one. First, you check the network adapters. This is what you're going to do. Once the checking network adapter is done, saying NC and that, then we can go for installing container runtime. So to install a container runtime, to run containers in a pod, Kubernetes uses a container runtime. By default, Kubernetes uses the container runtime interface CRI to interface with your chosen container runtime. If you don't specify a runtime, kubeadm automatically tries to detect and install container runtime by scaling through a list of known endpoints. If multiple or no container runtimes are detected, kubeadm will throw an error, will request that you specify which one you want to use. If you don't specify a runtime, kubeadm automatically tries to detect an installed container runtime by scaling through a list of known endpoints. If multiple or no container runtimes are detected, obviously that's gonna happen. It's gonna throw an error. So here you can find out some for Linux containered Unix at this location, path to the Unix domain socket, and CRIO container runtime interface, and Docker engine. So all. Then let's begin installing the kubeadm, kubelet, and kubectl. So to install kubeadm, the command kubelet and kubectl, we will see. This is the actual process for Debian based distributions and Red Hat based distributions, and without a package manager you can use a curl directly without using a package manager. You can just copy this and use it, but let me go for Debian based. So first you update the apt-get package, then install apt transport https certification curl, then you curl the public signing key, it could be GPG key, Then you add this Kubernetes apt repository, and then you install the kubelet, kubeadm, kubectl all together, and apt mark hold kubelet, kubeadm, kubectl. So update apt package index, and install kubelet, kubeadm, kubectl, and pin their version. So that's it. That's how we do installation of this. So begin you basically check your prerequisites, check network adapters, verify the MAC address and product UID are unique for every node, and check required ports. Then installing a container runtime interface. Then that's it. And finally, you can install your kubeadm, saying installation of kubeadm using based on if it is a Debian based sudo apt-get, and update your app package index and install needed to use the Kubernetes app repository. Then download the Google Cloud public signing key. Then add the Kubernetes app repository, and finally update app package index, install kubelet, kubeadm, and kubectl, and pin their versions. So you can say kubeadm init config kubeadm config.yaml. So to configure your C group driver, yeah, see, this is our config.yaml for the this one. Of course, the files won't change much. There won't be, because fundamentally either it could be kubeadm or kubeadm or minikube or docker desktop um, kubernetes extension, all are used to create a kubernetes cluster, and fundamental actions will be taken care by the kubectl. And here to initialize that, you need to have a config.yaml, and we'll use kubeadm in it. So such a configuration file can then be passed to the kubeadm command. Then let's look into an example at deploying an application. So one by one, step by step, we will look into that. So we will begin with in this example, we will deploy the WordPress content management system with a MySQL backend that we have done in our previous example with in COPS cluster. So that's why I'm not going to repeat this practically. I'm not going to practically demonstrate this. I just want to show what all steps are involved in this and what all files we have to create. That's it. Nothing much. So that you can understand the difference between the kubeadm and the cops. So yeah, only difference is cluster, how they handle the cluster. That's the main difference. Anyway, we are going to deploy that WordPress content management system with the MySQL backend. So it's a classic two-tier application where the first tier is the application server, that's a WordPress, that uses the second tier for data persistence, that is MySQL. So let's begin with our first step. It's create a Kubernetes secret. So what is a Kubernetes secret? Everybody knows. By the time you also might have known Kubernetes secret, as discussed before. Kubernetes secret allow users to pass sensitive information such as passwords, database credentials to containers. In the first step, we need to define a Kubernetes secret that contains a database name, user, and password. It should also contain the root password for MySQL. So you can see that we have created a lot of secret files also, and here API version, kind, and then metadata. Name of this is app secret, and type it's opaque, and data here are that. So this is key value pair. Key is the data name, and then value is the encrypted or encoded password. So these are all encoded passwords. So before creating a secret, we need to encode such information in base 64 format, saying echo, and mention the string that you want to encode it, and then pipe it with base 64. We have done it. So once that is done, now that we need to provide a database a root password to allow WordPress to create the required database to encode the values of base64 format. We can use the standard Kubernetes standard base64 utility that's available in almost all Linux distributions. So base64 format encoding, for that we'll say yeah, this is how we do. We have done it. We have taken a lot of examples. However, see, the password app db is one password, app user is another password, app pass is another password, app root pass is another password, and all were encoded to base 64 using this commands echo option n, and then mention that in strings, and pipe it with base 64, and that password which is mentioned as a string will be encoded or encrypted, encoded. Okay, so now let's define. So our secret file for all are done. App db, app user, app pass, app root pass, all are done. So secret file, secret definition file has been written. So now to define a Kubernetes secret, we have to create a new file. Okay, that's done. And then what we have to do is now we can create our Kubernetes secret using its definition in the app secret.aml. We'll say just kubectl create f and then file name, or else you would say kubectl create or kubectl apply option f app secret.aml. So basically, the only difference that takes place between the kubectl and kubeadm is the way you set up the cluster. That's it. Setting up the cluster is different. Installation of kubectl and kubeadm and kops is different. Other than that, rest all same. The remaining deployment and application, the number of files, everything is same, because you just want to create a production ready cluster. So that's it. If you are able to create a production ready cluster, that means all work will be done by the external users who will just push the code into that, and it will automatically should spin. That's what the production ready cluster, and that we'll be doing. We have done it using cops, and now we'll be doing with kubeadm, but the process remain same. So we have created that, and now let's verify the secret creation. To verify that whether secret object has been created or not, we'll say kubectl and then get secrets, and you see that our app secrets, the secret object has been created. So the first step, creating a Kubernetes secret, is successful. Next we will move on to the second step. So here we are going to create a persistent volume. We're going to create a persistent volume. So we will create a Kubernetes persistent volume to provide the underlying storage for our MySQL database. So to define a new persistent volume, we have to create a file called app.pv.aml. Basically, this is a persistent volume definition file. So app pv.aml, so you have to mention the kind as a persistent volume type object, because we have discussed there are so many objects, out of which persistent volume is one type of object. So we can create that also. So name of this persistent volume is app hyphen pv, and labels volume mysql. This is specifically a persistent volume, that too it's for mysql, so that's the reason. Then we have a spec. So storage 1 GB, access nodes, read, write once. So we need to have all the permissions to that. And then host path is /data /db. So in this file, we use a host path volume, which will just pass a directory from the host path into a container consumption. To specify that to specify that the persistent volume will be used for our application, we added a label called volume and then colon mysql, so that can be used to used in a used later in a selector. So now before creating the actual persistent volume, verify that directory or data or app exists. So let me do that. So for that I'm going to say sudo make dir /data/app. So now we'll create our persistent volume. So we'll say kubectl create option f, and the file name is app option pv.ml. Then we have to verify that the persistent volume is available. Let me say kubectl get pv. That's it. Or else you can say kubectl. We can describe that persistent volume also, saying kubectl describe and then persistent volume pv forward slash persistent volume name. What is that? It's app hyphen v. That's it. So the second step has also been successful, and the third step is to claim this persistent volume. So to define for MySQL, we need to claim our previously created persistent volume. So create a new file saying app pvc, that's a persistent volume claim.ml, and this file consists of this information. Name of that would be whatever they want, app pvc. Access mode is 191. Read write that we're gonna look into, and after that, what we're gonna see is to create the persistent volume claim using its definition. We will say kubectl create option f app pvc.ml. So once that is done, our persistent volume will be created. Now let's move on to the fourth step, that is deploy MySQL. That's where an actual deployment application has been built. So far, a persistent volume claim, and then secrets objects has been created. Now the main hero comes into the picture, that is deployment object. It's very powerful, very powerful. So now we'll create a new deployment for MySQL using the existing Docker image. Let's create a new file saying MySQL deployment.ml, and then this file consists of a huge amount of information. So name of this deployment is MySQL deployment replicas. This is a replica set. We want one replica set, one pod of replica set and templates. App name is MySQL, and inside that image, okay, this is MySQL, so I'm using MySQL 5.6 image, and then container port is 3306, and volume mounts is, this is the mount path where lab MySQL inside the container, and that should be, and this volume mount name is MySQL pod. So then environment variable, I have to give the MySQL root password, unless or else the database will not be initialized. If database is not initialized, then what's the point? If there is no database, how can your data be stored? So that's the reason environment variable you have to provide. And what's the password you want to take? You take that value from secret key ref. Yeah, here is that secret key ref. So name and app secret and db root pass. So then to create this deployment using its definition, okay, and few more things to be continued, that environment variables only. So one more thing is MySQL user. That's also we're going to get from app secret, and key is db user. The name of the key is db user, and the secret object name is app secret. Okay, if you want, I will show it again, but I hope you are following well. Okay, let me show that. Yeah, I think this is, yeah, you see that this is persistent volume still, persistent volume, and here you see how many app db, app user, app pass. So the name of the object is app secret, but in that object we have four keys: db name, db user, db pass, db root pass. So db pass I want this one, and then db user I want, and db name. So basically we should get this. So these are the keys: db name, db user, db pass. So you just copy this, and we will get into our deployment file. So there we're gonna mention these things. So you see that first key is db root pass, and second key is db user, and third key is db pass, and fourth key is db name, and fifth key is they have created on their own. That's a volume pvc. That's the persistent volume claim. Now let's create the deployment object using its definition file. So kubectl apply option F for MySQL deployment.yaml. Then let's verify the created wealth. Okay, let's verify that everything was created successfully. So now let me say kubectl and then get PV, that's persistent volume, PVC persistent volume claim, and kubectl get deployments to looking to see the deployments. That's it. The deployment has been created and a respective object also successfully created. Now it's time to move on to next object, that is deploying creating a service for MySQL. So as we know, pods are ephemeral. They come and go with each newly created pod receiving a new or receiving a new and different IP address to connect a database. To connect to a database, the WordPress application should know its IP address. So if the database container is ephemeral, then how should our application keep track of the databases or the IP? So to need a service of for MySQL, create a new file called MySQL option service.yaml, and this consists of the following information. Its name is MySQL service and port mapping is 3306, and then target port is 3306, and TCP selector is app is MySQL app. So service is this service is connected with the MySQL app deployment object. Then after the creation of actual service, then we will verify that service is created and corrected maply or not. You can see that. So kubectl get pods, we have only one pod MySQL, but however you could see that endpoint, that means the service has been correctly mapped. So then from that output above, we can verify that service was correctly mapped to the pod for our MySQL deployment in that endpoint to access our to address for the MySQL pod. Then we have to deploy the application. So all done, remaining objects were created properly. Now it's time to deploying an application. So deploy a WordPress. So to define a deployment for WordPress, let's create a new file saying WordPress deployment.yaml, and this is gonna consist of information about kind. That's what kind of definition file it is, a deployment file, and then metadata. Inside the metadata, the name of this deployment we're gonna give as a WordPress deployment, and replica set I'll go with 2, and strategy rolling update, and remaining information by and large remains same because we have done it same example in COPS cluster. So once the only difference is creating a cluster, rest all remains same. But I just want to I just want to take you through this exciting journey so that you will never forget that. So once the deployment file has been created, now you have to attach the environment variables, all the environment variables. So name WordPress db host, so you just give the value directly, and WordPress db user, that you can basically refer from our secret key ref. And then we have WordPress db password, that's also secret key ref. And WordPress db name, that's all okay, that one is also from their db name, specifically db name. Okay, so now let's create the actual deployment. Execute the command saying kubectl apply option F WordPress option deployment.yaml, and then the deployment WordPress deployment object was created. Then let's verify the deployment. Let me say kubectl get deployments. That's it. It will list out all the deployment objects which are present inside that cluster. Then get a list of created pods. It will fetch a list of created pods. Then the next activity for us is WordPress deployment is done. Now it's time for us to deploy, or after the WordPress deploy. So deploy WordPress, make note of the name of one of the WordPress pods from the output above. So execute an interactive shell within the pod. Okay. So kubectl exec and option it, that is interactive terminal, and then deployment WordPress deployment and bin bash. So with that we will enter inside the pod and inside the container. So now let's check that MySQL service can be resolved within the pod using service name or not. Okay, it's so now we have to say MySQL service, and then after that this above output verifies the MySQL service can be resolved through DNS to the cluster IP address that was assigned to the MySQL service. So now let's verify that WordPress is properly configured. So let us cross check wp wordpress config.f. So db name we have to give user password and db host. You can either give it from here, or you can also give it you can configure it after creating or after opening the application. Whichever way you want, you can go with that. The WordPress pod has configured itself using the environment variables injected into the container using the values from Kubernetes secret we define here. So then we have create a service for WordPress. Next, so the final step is to expose the WordPress application to external users. For this, we again need a service. In this step, we expose a port on the node running our application and forward that to port 80 of our container. So this allows us to access the application, but it probably is not the application, and one word and it's not one would take in production. So especially Kubernetes is hosted by a service provider, so Kubernetes can integrate with load balancing services offered by the platforms such as the Google Container Engine and AWS Amazon Web Services. So if you are using either of those, that would be an approach to take for using the balancing functionality offered by these platforms. Okay, so now this is the service file that we have written. So name of this service file is WordPress service, and app label is WordPress, and node port, the spec is node port type, and then inside that it's a node port you have to mention, that's a 30,080, and selector app is WordPress. So once the file has been written, it's time to create the actual service using the definition from the wordpress.yaml file. So it execute the command. So let me show you that. So, okay, once that is done, we can say kubectl describe, and then service name we can give so that it will describe about the service. So then we have the next step. This is to test the WordPress application. So far we have written all the required definition files, and now we have to test the WordPress application. So open for that. So all deployment done, all services are done. You have to get into your Google. If it is Google, you have to get into the Google um, uh, GCE. So that's Google Cloud. If it is AWS, you get into the AWS and take the uh, uh, load balancer IP, and then paste it in the browser. You should be able to access that application. So, and port number, if you use a load balancer, the port number could be 80. If it is some other way, you can basically you can use 30,080. Okay. So I hope you follow the installation wizard to get the WordPress up. After the once WordPress application is up and running in your browser, then you follow the installation wizard to get WordPress running through the browser. So if you are able to do that, a big congratulations, you have deployed an application inside the cluster which was created by kubeadm. Also, of course, deployment of application, the definition files that we have written, the quantity the content that we have written, everything remains same, but the cluster changes from kops to kubeadm. And this is the kubeadm deploying an application. So here you could see all the services, all the sorry, not services, all the objects. from secret object. You see that secret object is connected with two pods. One pod is MySQL pod and second pod is WordPress pod. It's connected with the two. And after that we have uh, volume claim objects. This is volume persistent volume object, which is labeled as a volume MySQL, and which is connected with MySQL data, MySQL container pod. And then we have a service pods. Obviously service pod, as to you have two service pods you can create, one for the MySQL, second one for the service selector. So basically the point here is the MySQL service is used to connect a MySQL database with the WordPress application, whereas the service which is used with the WordPress application is used to expose this WordPress application to the external or outside network. So in production, we may want to update the WordPress deployment, increasing the number of replicas to handle the high load or the high load for the application. So we can easily do it manually, but the preferred way in Kubernetes is to un auto auto scaling feature for the MySQL deployment. In our example, there is no simple way to increase the number of MySQL or pods, because we cannot share the same persistent volume between several MySQL resources or processes. So MySQL does not support that. Thus, to scale database and make it highly available, we can use, for example, a Galera cluster in the multi. So there are a few more things basically you can do, but for now you should be able to see this picture. So where you have all the Kubernetes objects are visible on your screen, from pod and container, WordPress pod, two WordPress pods and two WordPress containers. And then these are the labels: app, WordPress. And similarly you have a volume claim and persistent volume claim, and then secrets file. So secret file is very secret and that should not be revealed, and it will be, the secret file will be used or connected by the WordPress pod and then WordPress container and then MySQL container inside that. So with that, we have seen the Kubernetes. We have seen the creation of Kubernetes cluster using the kubeadm, and after that we have taken the similar example, WordPress MySQL, a two-tier application to deploy in that cluster, in that kubeadm cluster. So Kubernetes is an open source project, and it will supported by the community. So if you get any doubt, you can basically put that doubt in their official website. You can address that, and uh, you can ask the doubt, any queries in Kubernetes official website. They have a very good community, and they respond. They get back to us within very less time. So that's a good thing. So that's what all about Kubernetes. And so far we have seen uh, what is Kubernetes, and then what is pod, what is single container pod, a multi-container pod. If it is multi-container pod, how many containers we can have, what type of containers we can have. And after that we have jumped into the action, and there we started working on our clusters. So two single node clusters with Docker desktop and then Kubernetes extension, and then another single node cluster using Minikube. And then we have created a cluster using kops, and inside that kops cluster we have deployed stateless application and stateful application, stateless application of guestbook and stateful application of WordPress with MySQL database. So that's what almost we have used Minikube, kubeadm, and kops. So we have seen enough. Now it's time to say goodbye to our most adorable and lovable Kubernetes, and time to meet on another module. And I'll see you there. Until then, Keep liking me, keep liking my videos, keep subscribing, keep loving it, keep enjoying it, keep spreading it. Until then, see you. Bye bye. And in another session, another mod, I'll meet you in another session, another module with more fun.